All right, welcome back everybody. I thought we'd do something a little different for sections 9.3 and 9.4 in Varburg, in your textbook Varburg. And that is, this video I'll do the 5 tests. And then we'll do another video with examples of each. So this is just going to be a convergence test. And for series, of course. And the one we've had is called the integral test. And it says if you have an infinite sequence, an infinite series, A sub n, well this converges if an integral from n1 to infinity of the function that emulates this converges. And we're essentially taking a limit of that. If and only if this converges, each converge. Then this gave rise to, the P-series test, which are flavored like this: 1 over n to the p, where n goes from 1 to infinity. And these kind of series will converge if p is greater than 1. If p is less than 1 or equal to 1, it diverges. And in particular, when it is equal to 1, note p equals 1, it's called the harmonic series. It looks like this. And it diverges. And that's important for us going further, because the next 2 tests are going to be comparison tests. And if we know about the P-series, we're going to have to come up with another series to compare the one we're looking for. And if we know about the P-series, that's going to be very helpful. So the next one is called the ordinary or regular convergence test. Ordinary, that's what your book calls it. Comparison, sorry about that. Comparison test. And all we're saying, let's see, if you have a series in which one part of the sequence is always less than the other, this is strictly, sorry about that, then just note, how about that? Note, if this is the case, the A sub k is absolutely less than the sum of the series B sub k. The lesser series, the greater series. And so what we're going to say is if the sum of B sub k converges, if the greater series converges and it's less than, and it's greater than, the other one's less than, then certainly H converges. And vice versa. If the smaller one diverges, certainly the big one diverges. The ordinary comparison test, we actually used this once to do an example. And we'll get, we're going to talk about examples of all of these. Here's brand new ones. There's 2 of them coming. One is called the limit comparison test. And the limit comparison test, you have members of a sequence being greater than 0. And this one's greater than or equal to 0. This one is just strictly greater than 0 because that's going to be a denominator. Excuse me. And the limit as n goes to infinity of A sub n over B sub n, whoops, where are we? Yeah, is some number L. That's this is the sequence. If the sequence, one of the sequence divided by the other sequence goes to L, and further, if 0 less than L, less than infinity, then both series converge or diverge together. Then both series either converge or diverge. Together. If one converges, the other converges. Furthermore, if L is equal to 0, sorry, it's so low. Furthermore, if L is equal to 0, and the sequence B sub n converges, so does A sub n. Whoops. Yeah. Okay. And one more. It's called the ratio test. This one is my favorite, actually. Note the last two, we were comparing series. We were comparing series to other series, outside series. Well, this is called the ratio test. And this is it's a comparison to itself. To itself. And it's pretty simple. You have some kind of series. I think it has to be greater than 0, given some given some kind of series. If the limit, let's see here, yeah, the limit of from the sequence a n sub 1 over a sub n is well, let's see. If that limit as n goes to infinity, I'm taking the n plus first one and divided by the nth one, and if that is less than 1, if the limit is less than 1, series converges. Whoops. If it is greater than 1, series diverges. If it's equal to 1, we're unable to tell. No conclusion. We can't tell. And actually, we'll do an example of one that converges and diverges the next time we get together. So hopefully that was helpful. Thank you. See you next time.